All right, welcome to class today. Sorry I can't be there, but we're going to go through and talk about the worksheet today. So this is Module 2, Lesson 16. If you got your module book, feel free to follow along. If not, you can use the worksheet right here. So number one, we have a certain time of day. There's a flagpole that casts a shadow that's 8 meters. We also have a tree, and the length of the shadow of the tree and the flagpole actually have the same distance, like the shadow ends at the same point. So what I want to know is what equation can we set up that would allow us to find the height of the tree? And so essentially what I want to focus on is that I have these two triangles that are sharing these angles, and therefore, since we have two 90-degree angles and these two reflexive angles, that these two triangles are actually similar. And so what we want to do is make a proportion from the sides. So we could say that h in the tree over 12 for the pole is equal to S for the tree over 8 for the pole. And then we could cross multiply and solve if we need to. Here we can't because there's two unknowns, but that's the equation we would make for this question. So using that same strategy here, we're going to create and solve for the missing sides. So we know that we have these two sides, A prime, C prime, and AC, okay, that are in corresponding positions. And then I'm trying to find the length of CB, and I can see I have these two corresponding sides. So we could call the length of this X. And then I have another side length AB on the bottom, and I'm looking for the length of this, and we could call that Y. So I'm going to want to create a proportion to solve. So we can go, let's say, big to small, so 4 over 12, okay, is equal to X over 6. So I'm going from ABC to A prime, B prime, C prime, and both of those. And I cross multiply, so 12x is equal to 24. And then I divide by 12, and I can get x is equal to 2. And then in the y column, okay, we would do the same concept here. So I could do 4 over 12 is equal to, and here I have 5 over y. And so cross multiply again, 4y, 12 times 5 is 60. Divide out by 4, and we're going to get y is equal to 15. All right. There's another option, which is to actually do ratios in between the same triangle. So if I were to, for example, find y again, but I was to use the ratios in each triangle. So only using triangle ABC, I could make a ratio of 4 to 5. That's an in-triangle ratio. I'm using the same exact relationship here. I can do 12 to y, and I can cross multiply, and you'll see I'll still get 4y is equal to 60. So we're going to be talking about those two main things today. Ratios from one triangle to the next, and then ratios from inside the same triangle, okay? And then we'll get into using scale factors as well. So number 3, we got a flagpole, and for some reason, my numbers are all messed up. I know yours aren't. So this line from here to here, oh, that's not what we wanted. Just ignore these guys for now. All right. The picture's all messed up, but okay. So we know the length from here to here on the tree. On the tree. Wrong question, Mr. Z. On the flagpole here, this is 60 meters, right? The whole thing going all the way across is 170 meters. Okay. We want to know the height of the building is H. All right. And the height of the flagpole we have is, I can't see what it says. Yeah, I'll look it up. Hold on. Pause. 35 meters. All right. So in the same concept here, we want to know, are the triangles similar? And we would say yes, the triangles are similar since there are two sets of corresponding corresponding angles that are congruent. And we can mark those down. So we know that the building and the flagpole are on the same level ground, so they're kind of perpendicular here. And we also know that they're sharing this angle. All right. Using the same question here, okay, hey, look at that, it worked. Determine the height of the building using what we know about scale factors. So now, if we look at the relationship between this line and the whole segment, we can figure out the scale factor, okay? So let's let R represent our scale factor. And we remember what we said, if we want to grow, we want to do bigger over larger. So one ratio we can make is 170 over 60. And if we have a calculator, hold on. All right, with our calculator, we can just do we can hit menu and open up a calculator page. And then we're going to want to type in our ratio, which is 170 over 60. And we can reduce that down to 17 over 6. The calculator will reduce this down to lowest terms so that we can work with smaller numbers. And so if I want to figure out what h is, right, I just take the side I'm looking for, which is 35, and I multiply it times my scale factor, which is 17 over 6. So if I just take 35 times, and I'm going to hit Control Divide to open up my fraction bar here, and then 17 over 6, and I get 595 over 6. And I can hit Control Enter and get that decimal. So it's 99.16 repeating here. Meters. So that's how we could use scale factors. Now, if you want to do the same thing, we could use a proportion, right? 60 over 170, and then the same ratio would be 35 over h. And so you see, I'm still going to do 35 times 170, right? And then divided by 60. So 35 times 170, right, divided by 60, and we're still going to get that same answer here, okay? So determine the height of the building using ratios between similar figures, and so we just literally did that, right? 60 over 170 is equal to 35 over h, and so when I cross multiply, 60h is equal to, and we now know that that is 5,950. And so when we divide by 60, we already know our answer is going to be 99.16 repeating. And if we want to use ratios within similar figures, then we're going to stay within the same triangle. So here, we could make a ratio of, from the smaller triangle, we could say 60 over 35. And then in the bigger triangle, we would say 170 over h. If you're noticing, we're still cross-multiplying the same numbers together. So 60h is going to equal 5950 divided by 60, and we're going to get h is equal to that 99.16 repeating number. So that's the key here, okay? Is that we can either use scale factors, we can use ratios between the two figures, or ratios within similar figures. All right. So this next question, we know that these right triangles are similar. They're telling us in the question. We will determine the unknown size of these triangles using ratios. I'm just going to pay attention and read the directions below. So for each of the triangles below, we define the base as the horizontal edge, the bottom here. Okay, the height is the vertical length, and then the hypotenuse is going to be the long side over here. Okay, so for question A, write and find the value of the ratio that compares the height of the hypotenuse of the leftmost triangle. I think we're missing something there. Hold on. Compares the height to the hypotenuse of the leftmost triangle. So the height would be 4, right, to the hypotenuse, which is 5. All right, and so we want to find, now in part B, find the value of the ratio that compares the base to the hypotenuse of the leftmost triangle. So the base is 3 and the hypotenuse is 5. All right. Find the value of the ratio that compares the height of the base to the base of the leftmost triangle. So the height is 4 to the base, which is 3. All right. On to the next one. Part D. I feel like I'm missing something here, but that's all right. Use a triangle with lengths 3, 4, and 5. So I recopied those two triangles from the last page over here for us. Which is the ratio that can determine the height of triangle A? And so if this is my height, we'll call it H, I can compare the lengths in these two corresponding pieces here, okay? So if we want to do 3 over 4 is going to be a ratio that will do that for us. If we're going to set up a proportion, we're going to want to say that would be equal to 1.5 over H, and then we could solve. Likewise, we could also do, if we want to do from triangle the left to triangle A, we could do 3 over 1.5 is equal to 4 over H. And you notice we're going to cross multiply the same things here, right? Okay, and so let's go find it. So 3 over 4 equals 1.5 over H. We're going to cross multiply and solve here. So 3H is equal to 4 times 1.5, which should be 6, divided by 3, and we get H is equal to 2. All right, so the two ratios we're using is 3 over 4 and then the 1.5 over H, and then we're just creating a proportion to solve. All right, question number E, which ratio can determine the base of triangle B? We'll call B for base, right? So since I'm using these two and these two, the ratios I can use are 3/4 from the first triangle, and in the same order, we're going to go B over 5 in the second triangle. Okay, so the two proportions I can choose, if I want to go from one triangle to the next, okay, is going to be 3 over B and then 4 over 5. And if I want to go from inside the same triangle, I could do something like 4 over 3 equals 5 over B. And so when we cross multiply, we're still going to be multiplying the same thing here. All right, so this is going to be 4B is equal to 15, and then we're going to divide by 4, and we'll get B. And this should be 3.75, I believe. 15 over 4, 3.75, all right. For part F, same thing with choice C here. We want to find the height, we'll call this H of triangle C. And so which ratio can we use? Once again, we're using these two corresponding sides. So we can compare 5 to 4, okay? And use that to compare 8 over H. And I can also compare from the left triangle to the right. So 5 over 8 equals 4 over H. And so you can see I'm always cross multiplying and getting the same amount. And so now we're going to find the unknown lengths. We're going to get 32 is equal to 5H and divide by 5. And we're going to get H is equal to, and then 32 over 5 is going to be 6.4. All right. So you guys, for homework, are going to finish up these guys right here, okay? And I will see you guys on tomorrow.